Okay, so now we're going to talk about percent by mass. So it is a percentage, so there's going to be part of something over the whole thing times 100 to make it a percent. Because it's by mass, we're going to do the molar mass of the element in a formula divided by the whole molar mass of the formula times 100. Okay, so let's look at this example. I'm going to pause this so you can copy it down, and then we're going to talk about how we would approach this. So in order to work this out for hydrogen, the first thing we're going to do is find the molar mass of hydrogen. Now in this formula, there's 2 hydrogens in water. So the molar mass of H2 over the molar mass of H2O times 100. So that's just how to set it up. We need to plug in the molar masses then. So for hydrogen, there's 2 of those, so it's going to be 2.02 is on the periodic table. 2 times 1.01 is this. And then the molar mass of water would be 18.02 times 100. So can someone solve this for us so we can get an answer, please? Then it's a little bit bigger right now. I'm going to go ahead and set up oxygen and maybe
11.2.
Okay, 11.2 what? Let's go to 2 decimal places.
20. So that'd be 21 because there's a 9.
Oh, okay. So 11.21, and then don't forget to write percent with your answer because these are percentages and that's like a unit. Okay, and then Emma, can you solve this next one for us? We're going to do the molar mass of oxygen over the molar mass of water times 100 again. Now, our molar mass of water is the same thing we already calculated, so we don't want to figure that up again. And then oxygen is 16. Also, while Emma's doing this, I totally forgot that, okay, Emma's writing. I'll do it. I totally forgot to tell y'all that multiplication and division is going to give you the same answer regardless of what order you do this in. This answer is 88.79%. Okay. Now, I can check to see if I got the correct answer by taking my 2 answers and adding them together. And what should we get if we add all of the parts together that are percentages? What would they equal if they were all added
100.
together? 100. All right, so if I look at these and I get at least 99.99, then I know I did it right. So it checks out. That's a good way to check your answer and make sure. Yes, ma'am. So on the first one, we did 2.02 divided by 18.02 times 100.
What is 2.02 hydrogen times 2?
So yeah, that's just 2 times 1.01 off the periodic table. Yep. So good answers. I was saying it, I think, while you might have been writing it down. So it's hard for all that to register while you're copying things. Okay, so in water, we have hydrogen and oxygen. We found the percentage of both of them. So if you find the percent by mass of every element in a chemical formula, then that is called percent composition. Okay? So percent by mass is not going to be a huge component on your test. Just know how to do that. And what we're going to learn and spend the most time on is taking the percent composition given, those percentages, and then trying to figure out what the chemical formula is. Okay? So, does anybody feel like we need to do one more example just to make sure this makes sense? Yeah, I'm getting some that said yeah. This again, this is calcium and chlorine, not carbon and iodine. Okay? So if we did the percent by mass for each one, we're going to have the percent of calcium, that's going to be the molar mass of Ca over the molar mass of CaCl2 times 100. So y'all need to look up those masses on the periodic table, figure out what that, so the top number is 40.08.
39.
2 chlorines and 1 calcium. Chlorine's like 35.45. Just to save y'all time, we did this last period. 110.98 is CaCl2. Okay? So what's our percentage of calcium? Okay, not everybody is writing. However, nobody is even working this out, I don't think.
So I was writing.
Right, but not everybody is writing. So this percentage to 2 decimal places is 36.11%. Okay, and then for for chlorine, that's going to be the molar mass of 2 chlorines, which is 70.90. I'm just going to take a little shortcut because we know how we would set it up. I'm just going to show you the numbers that would go in the numerator and denominator. Denominator is the molar mass of the whole thing again, which is 110.98, then times 100. So that is going to be, should be, this, like whatever this is, minus 100, but we just want to make sure we get it right. We don't want to assume that that one's right in case we made a mistake. So this is 63.89%. Okay, whoops, this is a percent sign. Okay. So any questions about either of these? No? Okay. So this is finding the percent by mass of each element, which is called percent composition. Now we're gonna go and work the other way around. We're gonna take the percent and solve for the formula. So the formula we would be solving for is called, can I scroll on? It's called the empirical formula. So copy this down. I am not going to test y'all on definitions, but I want y'all to understand what the empirical formula is. Probably Thursday. That's tomorrow, right? So probably Monday we'll go over molecular formulas, and we'll be done with the unit. So empirical formula, that's going to be the formula with the simplest whole number ratio of subscripts. Okay? So it's the smallest number that the subscripts can be. Looking up here, there's 2 examples. One is an empirical formula and one is not. Remember, empirical formula is the simplest whole number subscripts. So we just got to see if the subscripts can be further simplified or not. Okay? So do you think this is empirical formula? Yes or no? All right. Y'all are right. You're not. Okay, so this is empirical formula. Totally said no. All right, so this is an empirical formula. This one, what do you think? Yes? No. This one is not, because both of the subscripts are 2's and they can be simplified down to 1's. Okay? So that's the difference. But this reminds me of a joke. I'm going to tell a lame joke. All right, so and it's not about beer or anything, but a bartender walks into a bar. I mean, wait, not the bartender. A guy walks into a bar, my bad, and says, "Hey, bartender, I'm thirsty. I want some H2O." And then the guy sitting beside him was like, "Hey, that sounds pretty good. Hey, bartender, I'll have some of that H2O too." Well, the second guy died after he drank it. Which, that's not the funny part. The funny part is you have to know your chemistry.
I like
So here's the thing. So this wasn't a dark humor joke. It was kind of like a chemistry joke because H2O is water, but H2O2 is not water. This is peroxide. And actually, drinking peroxide will not kill you, but don't drink it. It will not kill you.
Look how she looked at you.
It will, just in case. We will not name names because we are recording. But drinking peroxide will cause you to vomit, so that's not going to be good. But it was just funny because the guy was like, "I'll have some H2O2," and literally, it's not water. So, yeah. That concludes my little joke. Okay. So, next thing, we've got to know how to calculate the formula from the percent composition given. This is something that you need to copy on this slide. Every little detail, please copy down. You're going to need I'd say by Tuesday, commit this to memory because you will need to know how to do this for the test. And let's just say that you're taking the test and you're like, I know there's 4 steps, but I forget what that second step is. I got stuck. Instead of leaving that question blank on the test and risking missing the entire question, if you need my help on a test to tell you one of those steps, you can ask me and I'll just take off a couple of points and you can get the majority of that question right after you get a little bit of assistance. Does that make sense? Mm-hmm. So that's where you might ask me questions during a test and I'll give you the answer but have to take off.